solve the equation and express the solution in exact form. We've been given log base 9 of x minus 4 plus log base 9 of x minus 4 equals 1. We're going to use the properties of logs to rewrite this and see if we can solve for x. Now, when you see addition in a logarithmic equation, you should be thinking product property, meaning we can go from the sum of logs, assuming that the bases are the same, to the product of a single log, and the product will be the argument. All right, so we can say instead of log base 9 of x minus 4 plus log base 9 of x minus 4, we can rewrite this as log base 9 of x minus 4 times x minus 4 equals 1. All right, well, let's go ahead, FOIL this out. These are just two binomials. So we have log base 9 of x times x, x squared, x times negative 4 is negative 4, plus negative 4 times x is negative 4x. So we end up with negative 8x plus 16 equals 1. All right, fair enough. What we can do now is use our knowledge of going back and forth, the conversion between logarithmic form and exponential form, and we can say 9 to the first equals x squared minus 8x plus 16. All right, well, we've got ourselves a quadratic equation here. We're used to working with these. We know that we've got to set this equation equal to 0 and factor. Well, 9 to the first, that's just 9, isn't it? So let's go ahead, subtract 9 from both sides. That'll give us x squared minus 8x, and here we'll have plus 7 equals 0. All right, so let's go ahead and factor this. So this is going to factor into two binomials. So we're looking for factors of 7 that add to negative 8. Well, we know x squared breaks up into x and x. And factors of 7, well, 7 is just prime, right? So we've only got 1 and 7. And we want those factors 1 and 7 to add to negative 8. So both of these signs will be negative. Now, because these two factors are set to 0, we're going to use the 0 factor property to solve, meaning we're going to set each of these factors independently to 0. And I'm running out of room here. But you can see that x minus 1, if we set that equal to 0, we'll get x equals 1. If we set x minus 7 equal to 0, we'll get x equals positive 7. And so now we have two choices. So let's go back to what we were originally looking at and see if we can determine which of these two answers is correct. If we plug in 1 for x, we're going to get 1 minus 4, which is negative 3. But remember, we cannot take the log of a negative number, meaning the argument of the log cannot be negative, and so we know we're going to drop x equals 1 as a possibility. If, however, we plug in 7 for x, then we obviously get 7 minus 4, which is positive 3. That's a positive number. That's okay, and so we know that x equals 7 will be the final answer for x in number 43.